Hi everyone, welcome to another lecture video on technical mathematics conducted by Vadhyar Online Academy. In lecture 11, we discussed basics of trigonometric functions. In this lecture, we will focus on trigonometric identities. So let's get started. Let's begin our discussion with set 1 of trigonometric identities. The first identity says sine of minus theta is equal to minus sine theta. The second one says cos of minus theta is equal to cos theta. The third identity says sine square theta plus cos square theta is equal to 1. The fourth one says secant square theta minus tan square theta is equal to 1. The fifth one says cosecant square theta minus cot square theta is equal to 1. The next one says tan theta is equal to sine theta by cos theta. And next one says cot theta is equal to cos theta by sine theta. Okay, so this set of trigonometric identities are very simple. You must be familiar with all this. Now let's move on to set 2. The second set is like this. Sin a plus b is equal to sin a cos b plus cos a sin b. Sin a minus b is equal to sin a cos b minus cos a sin b. So these two are similar. The only difference is that here we have plus sign and here we have minus sign. Okay. Now the next one says cos a minus b is equal to cos a cos b plus sin a sin b. Okay. Cos a plus b is equal to cos a cos b minus sin a sin b. And the next one says tan a plus b is equal to tan a plus tan b divided by 1 minus tan a tan b. Okay. And tan a minus b is equal to tan a minus tan b divided by 1 plus tan a into tan b. Okay, so this is set 2 of trigonometric identities. Okay, now let's see one problem based on this set of identities. Problem number 1. Simplify the given expression 2 tan x by 1 plus tan square x. Okay, so you may try to solve this by yourself. Please pause the video and try to solve this question. Find out the right answer among these 4 choices. Okay, so to solve this, we should use the identity tan x equal to sin x by cos x. Okay, now here we are given a ratio 2 tan x divided by 1 plus tan square x. Let's replace tan x with sin x by cos x. So what we get is 2 into sin x by cos x whole divided by 1 plus sin x by cos x whole square. Okay, so let's expand this. What we get is 2 into sin x by cos x whole divided by 1 plus sin square x divided by cos square x, and this one we can rewrite it as 2 into sin x by cos x divided by this denominator we may rewrite like this, cos square x plus sin square x divided by cos square x. Okay, now we may use the identity sin square x plus cos square x equal to 1 here. So this term cos square x plus sin square x will reduce to 1. So what we get will be 2 into sin x by cos x divided by 1 by cos square x, 1 by cos square x. So this implies that this ratio can be written as 2 into sin x by cos x into, here in the denominator we have 1 by cos square x. So that may be written as cos square x divided by 1. Okay, so let's try to simplify now. Okay, here we have cos x in the denominator, here we have cos square x. So when you cancel cos x from both numerator and denominator, here in the numerator you will get cos x, and in the denominator you will get 1. Okay, so this expression reduces to 2 into sin x into cos x. Okay, so we know that 2 sin x cos x is nothing but sin 2x. Okay, so this ratio can be simplified as sin 2x. So here the right answer is given by option A, sin 2x. Okay. Now let's see another set of trigonometric identities. Sin 2a is equal to 2 sin a cos a. Cos 2a is equal to cos square a minus sin square a, which is also equal to 2 cos square a minus 1, and that is also equal to 1 minus 2 sin square a. So please be thorough with all these three definitions corresponding to cos 2a. Now tan 2a is equal to 2 tan a divided by 1 minus tan square a, and sin 3a is equal to 3 sin a minus 4 sin cubed a, and cos 3a is equal to 4 cos cube a minus 3 cos a. Okay, so please be thorough with all these trigonometric identities. These set of identities are very important when it comes to solving problems. Okay, now let's see one problem related to these identities. Problem number 2. Simplify the expression 1 minus cos 2x divided by sin 2x. Simplify the expression 1 minus cos 2x by sin 2x. Okay, you may try to solve this by yourself. Please pause the video and try to solve this. So we are given 4 choices here. Simplify this one and try to find out the right answer. Okay, so here we have to make use of two identities. The first one is cos 2x is equal to 1 minus 2 sin square x. Okay, and the second one is sin 2x is equal to 2 into sin x into cos x. Okay, so we may make use of these two identities to simplify this ratio. Okay, so if we substitute these two equations in this ratio, what you get is 1 minus cos 2x may be replaced with 1 minus 2 sin square x. So 1 minus 2 sin square x, okay, divided by sin 2x may be replaced with 2 sin x cos x. 2 sin x cos x. Okay, so here if we simplify the numerator, what you get is 1 minus 1, that becomes 0. Then when this minus goes inside, this minus and this minus gets cancelled, and we get plus 2 sin square x in the numerator. Okay, that one divided by, in the denominator we have 2 sin x cos x. 2 sin x into cos x. Okay, so here 2 is common in both the numerator and denominator. We may cancel those two. Then here we have sin x, here we have sin square x. So we may cancel sin x from both numerator and denominator. So numerator will reduce to sin x and denominator will reduce to cos x. So what we have here is sin x by cos x, and that is equal to tan x. Okay, so here the right answer is tan x. So that is given by option C here. Okay, so option C is the right answer. Okay. Okay, now let's move on to another set of trigonometric identities. 2 sin a cos b is equal to sin a plus b plus sin a minus b. Okay, so if you add the expansions of sin a plus b and sin a minus b, we will get it as 2 sin a cos b. Okay, now the second identity is 2 cos A cos B is equal to cos A minus B plus cos A plus B. Okay. So when you add expansions of cos A minus B and cos A plus B, we will get it as 2 cos A cos B. Okay. And now the third identity is 2 sin A sin B is equal to cos A minus B minus cos A plus B. Okay. So when you expand cos A minus B and cos A plus B here, if you simplify, then you will get it as 2 sin A sin B. Okay. So please remember these three identities also. These are also very useful while solving problems. Okay. Now let's see one problem related to these identities. Okay. Problem number 3. Find the simplified expression of cos pi by 4 plus x plus cos pi by 4 minus x. Find the simplified expression of cos pi by 4 plus x plus cos pi by 4 minus x. Okay. So you may try to solve this by yourself. Please pause the video and try to solve this by yourself. Okay. So here this question is derived, or it can be solved using the identities what we just discussed. So this expression cos pi by 4 plus x plus cos pi by 4 minus x is in the form cos A plus B plus cos A minus B. Okay, and this is equal to 2 cos A into cos B. Okay, so here in place of A what we have is pi by 4, and in place of B what we have is x. Okay, so this expression may be modified as 2 into cos pi by 4 into cos x. Okay, and we know that cos pi by 4 is 1 by root 2. So 2 into 1 by root 2 into cos x. Okay, so this may be simplified as root 2 into cos x. Okay, so here the right answer is root 2 into cos x. So that is given by option B here. So option B is the right answer, root 2 into cos x. Okay, so with this we will wind up lecture 12. In lecture 13 we will continue with trigonometric functions. We will discuss MCQs related to lecture 12 and lecture 11. Okay, in lecture 13 we will discuss MCQs corresponding to lecture 11 and lecture 12. Okay, so for upcoming videos you may subscribe to our channel Vadhyar Online Academy on YouTube, and for study materials you may subscribe to our Telegram channel using this link. So see you in lecture 13. Goodbye.